Hello and welcome to Cannon County High School Algebra 2. Today is Friday, and so we're going to do something a little easier because it's Friday. You already know how to find expected value, and we've already talked about games of chance like the lottery. So today we are going to be doing some expected values and games of chance, and we're going to be doing that using IXL DD.8. And so, Mr. Lyon, I think, let's see, by next week sometime, I think you get to take your mask off. So let's go right to it. Here is DD.8 on the computer. Zoom in a little bit. And we're going to be doing expected value. You already know how to do that. You just haven't done a lot of story problems involved with it. I think when we talked about expected value, I think I made up a couple of story problems and we talked about them informally. But we didn't, I think that the problems that we did with expected value at that time were where they just gave you a table of expected values, and now they're just gonna do the same thing, but more in story problem form. Not very difficult, but you still need to use the same logic that we used with the expected value. So here we go. There's a game where the outcome of a random integer from 1 to 50. If the outcome is even, you win $31. If the outcome is odd, you win nothing. If you play the game, what is the expected payoff? Okay, so let's see. We either win or we lose. If the outcome is even, we win $31. If the outcome is odd, we win nothing. So how many even numbers are there from 1 to 50? 25. How many odd, let's see, even numbers 25, there's 25 odd numbers also. So there's a half chance that we win and there's a half chance that we lose. So, and I'm going to do a lot of these on paper first, see how they make sense. But the probability that we win is a half, and if we win $31. The probability that we lose is a half. If we lose, we win nothing. Notice it costs nothing to enter the game. All it is you just win nothing if you lose. So a half times 31 plus a half times 0 would be the expected value. So on my calculator, I'm going to take 1/2 times 31, and that gives me $15.50. And when you type this in on IXL, make sure you type in 1550, not just 15.5, or it will give you, or it'll say it's wrong. Notice I didn't type in plus a half times 0 because we know that doesn't add anything to the problem. So, oops, I'm not sure why it didn't go there. $15.50 is the expected value. All right, let's jump up a level here. You'll get the idea pretty quickly. This is going to be a short video. All right, we're up to 55 here. In a raffle, 1 ticket out of 200 will win a $300 prize. 4 tickets win a $70 prize, and 8 tickets win a $60 prize. The rest win nothing. If you have a ticket, what is the expected payoff? Okay, so 1 ticket. There's 200 tickets. 1 ticket wins $300, 4 tickets win $70, and 8 tickets win $60. The rest win nothing. All right, well, let's set this up just the same way we did the other one. 1 ticket out of 200 wins $300, plus 4 tickets out of 200 win $70, and 8 tickets out of 200 win $60. All the rest of the tickets win nothing. Well, how many tickets are there that win nothing? 1 and 4 is 5, 5 plus 8 is 13. So 13 of the tickets win prizes, which means that 187 out of the other 200 win 0. So when you do expected value, you have to make sure you figure out every possibility. So you have 1 out of 200, 4 out of 200, 8 out of 200, and then you have to have 187 out of 200, so that when you add all the probabilities up, you know they have to add up to 1. You have to take care of every single probability. But you know that when you type this into your calculator, it's not really going to add anything to the expected value. So we'll just add up the first three. So we're going to type this into the calculator and see what we get. So here we go. 1 out of 200 times 300 plus 4 out of 200 times 70 plus 8 out of 200 times 60. And I'm not going to bother doing the plus 0. That gives me an expected winning of $5.30. So that means on this problem, every time you play this game, if you played it on average, you would win $5.30 on average. That's your expected value. Okay, so let's type that in. $5.30. There we go. Okay, let's jump up another level. All right, we're at 81. So let's see, this will be our last one. Let's see here. At a carnival, there's a game where you can draw one of 100 balls from a bucket if you pay $20. So, okay, the reason why this one's a little more difficult is this time we have to pay to enter the game, but we'll figure that out. The balls are numbered from 1 to 100. If the number on the ball is even, you win $18. If the number on the ball is odd, you win nothing. If you play the game, what is the expected profit? Okay, expected profit. That means it's how much we make after our expenses, right? So we have to figure that out. But the nice thing about this one is either you win or you lose. Either you win the prize or you lose the prize. So let's figure this out. Let's see. 100 balls in a bucket, numbered 1 to 100, even and odd. Well, we know the probabilities are a half and half, right? Because there's 50 even numbers and there's 50 odd numbers. Okay, so let's figure that out. We've got a half of a chance when we win, plus a half of a chance if we lose. We just have to figure out what happens in those two. All right, let's figure out what happens when we win. When you win, it says you win $18. How much did it cost us to play the game? It says over here it cost us $20 to play the game. So this isn't a very good game, is it? Because when you win, what is your profit? If it costs you $20 to get into the game and you win $18 when you win, well then what happened? You actually lost $2. So on this problem, when you win, you actually lose $2. And what happens when you lose? Well, it says when you lose, you win nothing. But how much did it cost you to enter the game? It cost you $20 to enter the game. So obviously this raffle isn't a very good raffle because when you win, you lose, and when you lose, you really lose. But that's the way it's set up. So that's where you got to be a little bit careful. You can't put in that you win $18 here because you're not really winning $18. You're actually losing $2 because it cost you $20 to enter the game. So when we figure this out, we're going to take a half times -2 plus a half times -20, and that will be our expected value. So every time we play this game, we lose $11. Oops, we lose $11, -$11. So that's not a very good game. And I think you remember from a few lessons ago when we were doing these that let's see, -11. Let's make sure that's right first. Sometimes how you set up the game, I think what we did, I think it was where we were doing a beta club raffle. Remember I had one beta club where raffle set up where I think we lost money and another beta club raffle where we made money. And how you set up the raffle makes a big difference. If this carnival game that we just worked on was an actual carnival game, I don't think people would play it very much. Once they figured out what's happening, that carnival game wouldn't get played. You want to make it look like you have a good chance of winning, but you also obviously want to set it up so that the house makes money. Okay? So try some of those. That is, again, let's see, that is DD8. So go to DD8. Again, this isn't a super difficult lesson, but go to DD8. That's a good lesson to end on a Friday, and I hope everybody has a good weekend. and I will talk to you next week. We have one more week of school to go. Bye.